to present on our project. It's a paper, and we have a methodological contribution. And what's the rationale of the study? So everyone says, well, the relation between agriculture, food, and nutrition is complex, and it depends on many factors, right? Agroecological factors, socioeconomic, institutional. So that means we need policies which are sensitive to local conditions. But if you look in the literature, you see basically the studies give you average treatment effects. So, for example, study of Bertinol and Massenol, 50 impact studies of agricultural interventions and their impact on nutrition outcomes. So we really have scarce evidence how the impact varies across localities. And that basically means that if you have a one-size-fits-all policy, it might easily be a hit or miss affair and will be inefficient, because you might basically focus on the right people or not always on the right people. So the impact evaluation literature is very aware of this, and it's really a methodological issue because we cannot observe the counterfactual. So for an individual, we cannot really tell what would have happened if we would have done it the other way around. So this is Heckman, you already noticed this, but this is generally realized. So what's a common solution? A common solution is to look at the people who are most in need. So for example, think about poverty mapping. So if you're concerned about poverty, you make a map, you look at who's the poorest, and you focus on them. If you are worried about job seekers, you look at the unemployed, the ones who have the most disadvantages in terms of searching for a job, and you focus on them. So it's the idea that basically impact is somehow related to need. So you target, and you don't know the impact of the policy, how it varies across the community, but at least you know how the need varies. So you assume that somehow need and impact are related. So what's the contribution of our study? Well, actually we think we can combine this idea of looking who's most in need, where most impact is. So we combine this profiling approach, looking for need, with an impact approach. And then we apply it to the relation between diet diversity in Zimbabwe and nutrition outcomes, and see whether this relationship, how it varies across different agroecological and socioeconomic factors in Zimbabwe. And then we ask the question, is it really the case that the ones who are the most needy, in this case the lowest diet diversity, are also the ones who will profit the most from a policy to improve diet diversity? So if you look at diet diversity and nutritional outcomes, well, we know from the literature there is a positive relationship. Some studies tell us that there's a positive relationship. And how is it in Zimbabwe? Well, we use the DHS survey. They have a 24-hour recall on the food groups consumed by children 2 years or younger. We look at the different food groups. There are 13 food groups reported in the DHS. We fit them in 8 groups. Actually, we have only 7 groups, according to the Swindale and Belinsky approach. And then we define as inadequate diet diversity, basically people have a score between 0 and 3. The total score will be 7, because that will be the total score if the child is actually consuming from each of the 7 food groups we have available. Normally it's 8. So we find, this is basically what we find, and we find about 83% of the kids 2 years or younger have a score below 4, so we call it inadequate. If you look at the regional variation, we see a correlation between diet diversity and stunting. So actually the regions where you have the lowest diet diversity, they also have the highest percentage of stunting. So first thing we did is say, okay, who's most in need? How does it vary across the country? So we identified 21 variables from the literature, which is often told to be linked with lack of diet diversity. So think about income, for example, think about the agricultural system. And then we selected 10 variables which were most predictive in the univariate regression of the diet diversity. And then we said, well, let's look at combinations of 5 of those 10 variables. And these are profiles. And what the lack of diet diversity is within those subgroups. So we look at a lot of subgroups which are made up of all kinds of combinations of those 5 variables out of the total 10 variables. And then, of course, if you look at profiles, you have 2 issues. You have an exclusion error and an inclusion error. So you could basically, well, maybe you are lucky, but you find people who have a low diet diversity in this case, but a lot of them you are missing. Or the other way around. Basically, you basically the inclusion error is basically you have people who who are in your profile, but they have actually they have adequate diet. So if you look at and then what we say is, well, we say, okay, we want to minimize the exclusion and then the inclusion error, and then the winning profile would be the combination of those 5 variables or their values, which gives you the lowest exclusion and inclusion error. So what do we find? Well, basically it's in rural areas. The alpha stands here for how you weight exclusion versus inclusion error. And we weight between 0 and 1. Well, for any alpha, you end up in the rural area. That's where the most need is. And you end up with mothers who are not working or don't have a job. And then it starts to depend a little bit on the alpha, but we find no twins, very young children, or young children between 6 and 12 months, a slope between 8 and 30%, so that's getting pretty slopey, and actually an area where you have at least 50% forest or barren land, that's where you find a lot of children with a lack of diet diversity. So that's a typical approach. So what do we do next? We say, well, what about where is the biggest impact? And we do propensity score matching first, and we estimate basically what is the treatment effect of moving from inadequate to adequate diet diversity. Well, we do all the tests, as you can see here, but on the bottom, you basically find that the average treatment effect on the treated is actually not significant anymore. So on average, you don't find actually a link between diet diversity and stunting. But then what we start to do, so these are all the tests, we start to look in more closely. And the first question is it really the case that the most needy are still the best target for policy? And what you see on this graph is basically the estimated propensity score, so that's the probability of having low diet diversity, and that's the average impact. And you see actually a positive relationship, as you would expect if need is actually linked to impact, but up to a certain point, up to a propensity of 0.7. So there is a relationship, it tends to be positive, but up to a point, so it's not monotonic, so it's more complicated. So then we start looking for different profiles, and there you could say, well, maybe we are just fishing. We take all kinds of combinations of people, and we start to estimate the average treatment effect. And then you can say, well, it's just a fishing operation. You will always find positive and negative impacts. Well, if it's really random, you would find something which is basically a lot of positives and a lot of negatives. That's not what you find here, because the average treatment effect tends to be to the right. That's important, it's to the right, because also, according to the literature and already early evidence, we know actually that the treatment effect tends to be positive. And the third thing we see is actually, as we increase the sample size of the profiles we are looking at, the group of people, it starts to shift even more to the right, and the group of people with a negative average treatment effect start to disappear. At 175, a sample size of 175, we have 0 significant profiles or significant average treatment effects which are still negative. So we really see all the evidence going only in one direction, positive average treatment effects, but only for certain profiles. So I have 2 more slides. Who are the winning profiles? Well, basically we have 36 profiles which are significant, when we have a sample size of 150. It's mostly children which are 1 year and older, which actually is also found in the literature that they often find that diet diversity is important, but not for the very smallest children, but a little bit older children. And here we have it from 1 year old. In 75 of the significant profiles, we see also rural areas, and then for 72% mother not working, no job. And here you see a number of other variables. So now the question is, well, what is the link between need and impact? So we basically correlate the two here, and we see that in terms of correlation, the R-square is basically 0.456. So there is a positive relationship. We see that need and impact are related, but it's not perfect. So you could say it's only half. Half of the variance is explained by basically need if you think about impact. So what's the conclusion? Profiling for impact is needed for policy effectiveness, but the needy are not always the best target. You can use a non-parametric approach to take into account this complexity. It's non-parametric what we are doing because we look at all kinds of combinations of groups. It takes 1.5 days actually to run the computer to do that in this case. Probably it can be programmed more efficiently, but I didn't have time for that. Maybe there's a trade-off. But we also need to consider how this one actually affects diet diversity. Of course, we haven't addressed that here. And what are the relative costs of targeting different profiles? Maybe one profile is very effective to focus on in terms of impact, but very costly to achieve. And maybe also the cost of changing diet diversity might also differ by profile. Let me stop here.